Okay, so the answer to this question is A, 0.25 over molar times minutes. If you're unable to find this answer on your own, just unpause the video and work through it with me. This is one of those questions I would highly suggest you understand very well because they always find their way onto an exam. So that being said, let's go through the problem. Using the above data, find the rate constant for the reaction X to products. So find the rate constant, that's K. And here are our experiments. We're given 3, we're given the initial rate and the concentration. So to go through this question, what we're first going to do is just look at a generic rate law. So rate equals K times A. We only have one reactant, so we're only going to have one thing in brackets to the M. Now what we're going to do is we're going to solve for K by making a proportion. So we can choose any two experiments. Just randomly, I'm going to choose experiment 3 and experiment 2. So what I'm going to do is write the rate law for experiment 3. Rate equals K times A to the M. And the rate law for experiment 2, which is exactly the same. So now what we're going to do is just plug in whatever information we were given. Starting with experiment 3, the rate of experiment 3 we were given, and that is 0.16 molar per minute. K we were not given. Okay, and A for 3, the concentration we were given. And M we were not given. Now let's just plug in everything we were given for experiment 2. The rate for experiment 2 we were given. K we were not given. The concentration we were given. And M we were not given. Now let's just simplify this problem a little bit. We can cross out our units over here. K is going to cancel out. The units of molar is going to cancel out. So what you're left with is 0.16 divided by 0.04, which is 4. I know this is very simple mental math, but when you're in a high pressure situation like an exam or a quiz, I would highly suggest using your calculator just so you don't make any silly mistake and get a question wrong that you really know and you wouldn't have gotten wrong otherwise. So we're going to do the same thing over here. 0.8 divided by 0.4 gives you 2, which is still in brackets, raised to the M. Now what we need to do is solve for M. So we're going to use a logarithm. We're going to take the log of both sides. And don't get freaked out by the log. It's not as bad as it looks. I promise. So now we're going to use one of the rules of logs, which lets us take our exponent in front of the log. So we have the log of 4 equals M, because our exponent came to the front, times the log of 2. Now we can solve for M. So M is going to be the log of 4 over the log of 2. Now we're running out of room, so I'm just going to move this over here and rewrite it just so that we don't get lost. All right, so now we can just solve for M by taking the log of 4, which is 0.602, divided by the log of 2, which is 0.301 equals m. Now we're just going to divide our numerator and our denominator, and that gives us 2 is equal to m. So now we've solved for m, but our question isn't asking for m, it's asking for k. But now that we have m, we can plug m into this rate law, which is the one variable we were missing. So let's rewrite the rate law. Rate equals k times a to the m. Now what we're going to do is we're going to choose any one of our experiments. It can be either 1, 2, or 3. They will all work. Just because we didn't use it, let's use experiment 1. Okay, so our rate for experiment 1 is 0.010. Our k for experiment 1, we're not given. Our concentration for experiment 1 is 0.2. Oops. And our m for experiment 1, well, we solved m, and that is 2. So let's just clean up this problem a little bit. Okay, so we have 0.2 squared. This is going to give us 0.04 molar squared. Now let's divide this by this side in order to solve for k. Here we can already see the molar in the numerator is going to cancel out. The molar in the denominator is going to become a 1. We're running out of space again. So our units are going to become 0.010 over 0.04 molar times minute. And let's just solve. The answer we find is 0.25 over molar times minute equals k. And another way to write this is 0.25 molar to the -1 minutes to the -1 equals k. So now we have solved for our rate constant k. It matches the answer that we were given. And I hope this was helpful.